Okay, so today I'm going to show you how to bisect an angle. We're going to start with adding two segments. First segment AB, and then the second segment is going to also include A. It's going to be AC. Now this is going to be our given angle. So next step is add a point anywhere on AB that you'd like. I'm just going to do right there. And now we're going to use this circle with the center from AD. So this is the radius of circle A. And you can add a point where the intersection is on AC. And we know that the radius is the same because the radius of the circle stays the same throughout the entire circle. And this is because of proposition 3. So next we're going to use proposition 1 and definition 20 to make an equilateral triangle. We do this by adding two circles with center, go to E, back over from E to D, and there's this intersection down here. And you're going to mark it with a point, and this intersection is now going to be known as F. So you're going to use the polygon shape, go from D to E to F, back to D, and now we have our equilateral triangle. So these 2 points are fixed, but if we move D, the triangle stays in the same shape. And if we move B, everything moves. We move A, everything stretches up. And if we move C, everything stretches to the right. So now that we have this done, you're gonna take a segment, go from point A to F, and we have now bisected the given angle. I'm gonna go ahead and hide these objects just so everything's not in the way as much. And I'm actually not gonna hide these ones. I'm going to make them dashes. So we can freely move everything around. Angles are going to stay equal. Triangle can move up and down, can get wider, smaller, but everything is staying equal still. So we know that we bisected this angle because of definition 20, which is basically just the definition that's describing the descriptions of triangles. So by definition, it says an equilateral triangle is a three-sided figure which has 3 sides that are the same length, and they all have the same angle. And then proposition 8 we haven't talked about yet, but I can show you. It's saying that if you were given 2 triangles that both have the same angles, both have the same side lengths, and their bases were equal to each other, then their angles are also going to be the same. So if we go back to my drawing, we know that because we use this radius from A to D, that side, that lines AD and AE are equal. And we know that if those are equal, then line AD and AF is equal to AE and AF. And then also the base DF is equal to EF because we used proposition 1 and postulate 1 to create an equilateral triangle. So just like before, DF and FA are going to be equal to EF and FA. So angle DAF F is equal to EAF. And that's how we know we bisected the angle of the given angle BAC.